Okay, so we are in the textbook shown here, Regression and Other Stories. We're in Chapter 2, and we'll look at questions 2.1 and I guess technically 2.2, but I'm skipping that because it's if you have the book, then you'll realize it's just very specific. We have to look through some literature and anyway, it doesn't matter. Okay, so question 2.1 deals with composite measures, which was mentioned at the first part of the book. So following the example of the Human Development Index in section 2.1, find a composite measure on a topic of interest. Track down the individual components of the measure and use scatter plots to understand how the measure works. So instead of doing that, looking through the literature, I thought that I could just use something that I think that probably a lot of people are going to be familiar with, and that's the body mass index. So the body mass index is a composite measure, right? It's a composite of body weight as well as height, and here's the formula for BMI. Also, instead of trying to track down a BMI data set, which you can do, I'm just going to make some fake data for BMI, okay? And so I've assigned height and weight and BMI into a data frame here called D, okay? And so now we're supposed to use scatter plots to understand how the measure works. Well, we already understand how the measure works, and so I think this question, or at least my answer to it, is going to be kind of limited utility, but nevertheless, so we're going to plot this, and I'm using ggplot. ggplot, if you're not familiar with it, I guess you'll become a little bit familiar with it right here. You could also plot this in just base R, but ggplot makes some of the things I want to do a little bit easier. So I'm going to have two plots, okay? And just to show you how ggplot works, so I call ggplot, and first I start by telling ggplot the data that I want to use. And then in the AES is for aesthetics, I talk about what the X variable is and what the Y variable is. And then if I want to layer on other dimensions, either in the form of size or color or shape, I can assign size or color or shape or whatever other dimension you want to add to another feature in my data set. And here it's going to be BMI. Okay. So I'm going to have height and weight plotted on the X and Y axes, and then I'm going to have points, the size of which corresponds to BMI. And then I'm going to have a second plot in which I'm just kind of shifting around these dimensions a little bit, where now BMI will be on the Y axis and the size of the points will be weight. Okay, so we're going to run this here, and this is what we get. So in the top plot here, we have height in meters on the x-axis and body weight in kilograms on the y-axis. Okay, I feel like I may have kind of overshot the body weight thing. I think maybe I've put a little bit too much emphasis on these larger body weights here, but nevertheless the point holds. Okay, so a couple of things. So in this plot, it's not surprising to see that height and weight are semi-linear. Okay, that's to be expected. Why? Because taller people just simply have a larger skeletal structure to put mass onto. Okay, and then also the pattern with size of dots. So if I go to any height here, as I go up, the size of the points, in other words, the BMI, gets larger, and it has to be this way, right? By our definition of the BMI. Okay. So here in the second plot, now I have again height on the x-axis and BMI on the y-axis. Now there's no clear relationship here, no linear relationship here, and that should make sense as well, right? Because BMI is a relationship between body weight and height. Okay. And so for any height, a BMI will be determined by this other value of weight, right? So there shouldn't really be a relationship then between height and BMI, and that's what we see here. But again, as I move up from any height, the points get gradually larger. And again, it has to be this way because for any given height, a larger BMI value, which is me moving up in the y-axis, requires that the body weight for that individual is larger than somebody with a lower BMI. Okay, so I guess that is it for this.